Bismillahirrahmanirrahim. And this is part 2 of the series of videos we are making for supercomputer on your desk. Uh, in this video I'm going to cover the SSH user equivalence, the host key collection, and the installation and configuration of parallel distributed shell, or PD shell, PDSH. Alright, I've already disabled unnecessary services on all three nodes. I have their IPs configured, and I am going to set up the rest of the OS in front of you. I will start with the etc host file, vi/etc/hosts, and I have this line here. Sorry, I'll share. This is not needed. This is IP version 6 naming, so I'm going to delete this line, and I'm also going to remove master node from this localhost line. I'm going to introduce three lines here. Master node is going to be 10.0.0.20, and node 1 is going to be 10.0.0.11. node 2 is 10.0.0.12. Fine, and I'm going to copy this etc host file to node 1 and node 2. Node 1, it doesn't know what is node 1. Okay, let's see. Node 1, sorry, this is totally opposite to what it should have been. 10.0.0.20 is going to be master node. 10.0.0.11 is going to be node 1. 10.0.0.12 is going to be node 2. Great. Copy this to node 1. Accept fingerprint of node 1, yes. Node 1's password is Red Hat. Do the same for node 2. Yes, and password Red Hat. Okay, done. So etc host file is now configured on both sides, on all three nodes. Right, next is going to be the key generation of the user root. What I'm going to do is I'm going to generate keys, public and private key pair of DSA and RSA of both of all nodes, not all nodes, of user root on one node only, and I'm going to copy that key pairs on all nodes. The reason is that you may be thinking that, oh, it's like 2-3 nodes and we can generate keys and we can exchange them, but in real life what we have experienced is that if you've got like 128 nodes cluster or 512 nodes cluster, you would not generate key pairs for the user root on each machine separately. It's going to be a one big mess to manage. I say this because I have experience, by the grace of God, of managing at least 12 128 node HPC clusters, and one in addition to them, one is 512 nodes cluster which is running on InfiniBand. So trust me once I say something on this topic, then you should trust me. Okay, what I'm going to do is generate keys. Okay, how do we generate keys? SSH keygen -t DSA for user root, and just press enter, no passphrase, and this key is saved in default directory. Let's change it to RSA and press enter, and RSA key is also generated. Okay, this screen should be a little bit up, I think. Okay, fine. Alright, so two keys I've generated. You can go and verify them in this directory. In the home directory there is a .ssh directory. Go into this one and see there is a file to these two files is one pair and these two files is one pair, public and private keys. This known host got created once we were copying files here to these nodes, this SCP. This is local known host, I should call it. This is local known host. There is a global known host which resides in etc SSH directory, and that is what exactly we will do in the next step. Right now what I'm going to do is I'm going to copy these 4 files, these ID files, to the SSH directory of all 4 servers, or all 3 nodes, or all nodes. I'm going to remove this known host, but it won't do me any good right now removing it, so forget it. Let's just simply copy it. cp -r dot ssh is to be copied to node 1 colon slash root slash. Okay, red hat gets copied, and node 2 as well gets copied. Great, but I was a little bit early in copying these files. Wait, I have to do one more step before copying them. Never mind, we can copy them again. Okay, I have to make sure that this node is able to log into itself, and these public keys basically get appended to a special file named authorized keys. So what I'm going to do is cat static.pub goes to file authorized underscore keys. Okay, it's in SSH directory. Okay, again, good. Now I'm going to copy these files, this directory again, to both nodes. Red hat. Now this file is also copied. Good. Node 2 as well. Fine. Okay, next is, now the keys are copied. Now I'm going to generate the nodes SSH fingerprints, RSA fingerprints, and I'll do that by using SSH key scan -t DSA for the nodes master node, node 1 and node 2. Oh, okay, great. So it scanned the DSA keys SSH2 for all nodes. I'm going to put it in a special file on this node in /etc /ssh/ssh underscore known underscore hosts. You see, this file is a valid one, but it does not exist by default. Now what I'm going to do is I'm going to scan the RSA keys of the same nodes, and I'm going to append that to this file etc ssh known hosts. Great. So this file should now look like this. Let me show you. etc ssh underscore known hosts. Okay, so as you can see, this file contains a lot of keys. No, not keys, in fact fingerprints. Okay, I need to replicate this file as well to all nodes. So what I'm going to do is I'm going to scp this file to node 1 colon /etc/ssh directory. Great. You notice it did not ask me for the password this time, because the key, the public key, was already attached and already certified on the other side. Now I'm going to do the same on node 2. Fine, good, it did not ask me the password. Fine, now we are going to test it by logging into each node. Node 1, let's start from master node, which sounds stupid, but it is required. The node should be able to log in as root to its own self. So it is successfully logged in, so just exit that. Let's log into node 1. Great, it's able to. Exit that, go to node 2. Oh, node 2 logged in. Good, great. Similarly, we should be able to log in from other nodes as well to all other nodes. Let's have this here. SSH master node. Great, it's logged in. Exit. SSH to node 1. Okay, let me give you a simple method. Why not do this SSH master node and just run a command over there, because that is what is required in the first place. Okay, let's do this uptime. Let's do that with node 1 and node 2. It is successfully able to log into all nodes. Good, fine. All nodes have same time. This is also important, although there is a few seconds of difference here. It should not happen. You should have an NTP server, and all these nodes should be directly adjusting their time from that NTP server as well. So we can do that in the later step. I'll show you how to do that. Right now I'm interested in checking up my or confirming my SSH user equivalence for user root, which is working great. Fine, let's go back to master node, because most of the stuff we'll be doing from here. And fine, let's check our steps. This seems to be like we have done this part and we have done this part. Now we are going to install PD shell. Fine, before installing PD shell, let me amend these steps as well. Let's call it step 3.1. Set up NTP server service. Let's call it service. Fine. What I'm going to do is I'm going to set up on my host computer, the host of these virtual machines, going to set up NTP service on this one. So etc ntp.conf, and let's disable this. By default it will load NTP service from its own. NTPD restart. Okay, so you can do NTPQ minus P minus N to see. Oh, we need to have at least one. Where is that? I missed that, I think. Yeah, this one, sorry. By default this is enabled, so it was disabled in my configuration. Okay, so this is localhost, so I'm going to restart NTP service. Great, and I'm going to do NTP minus P minus N, NTPQ, and it says that it has only one server. Soon it will have an asterisk here that it indicating that it is now bound to this time server. Fine, this is our what's the IP of this one? Let me see. This is 10.0.0.2. Okay, I'm going to minimize this. I'm going to master node etc ntp.conf. Oh, it doesn't have NTP service. Okay, let me copy the RPM. I forgot to set up the RPM repository for CentOS, so let me just copy that and I'll be back. Pausing the video here. So I'll just set up install NTP. Yeah, I need to copy, secure copy node 1 :/etc yum dot repositories dot t /CentOS base to this not to display /etc /yum dot repositories dot t. Okay, I install it again. Okay, great. Configuration of yum repository is beyond the scope of this tutorial, so that's why I'm not covering that. NTP is installed on this one. Done. On node 1 it's already done. I just checked that. Node 2, going to also going to SCP, the same thing. So okay, yum -y install NTP. So now I have NTP on all nodes. So what I'm going to do is I'm going to configure NTP file via etc ntp.conf. I'm going to set server is 10 server is 10.0.0.20, not 20, 0.2. That's my host machine for these virtual machines. I'm going to comment these out and service ntpd restart, check config level 35 ntpd on. Okay, so let's see what my ntp q -p -n says. Okay, it has also accessing. Okay, watch this. Soon there should be an asterisk here. Let me configure NTP on the other nodes. etc ntp.conf. Okay, so my server is going to be 10.0.0.2. These are going to be commented out, and I'm also going to comment out this local server just in case, and I'm going to check config level 35 ntpt on and service ntpt restart. Node 2, I'll just why not simply scp etc ntp.conf to node 2 /etc ntp.conf. Good, and go to ntp.conf and check config level 35 ntpd on and service ntpt restart. Okay, so what do I have here? Still don't have a confirmed time clock, but I have ntpq -p -n. This one, this node 1, it's going to connect to this machine anyway because I left it no choice. So same I'm going to do on master node. I'm going to edit the NTP file here on master node. I'm going to comment out the local loopback address. I'm going to do service ntpt restart on this one. Okay, so tpq -p -n doesn't say anything, but k workhorse. Okay, this is my host machine on which I set up NTP server, and it says that it's bound to its loopback address. I'll just minimize this. I'll just wait for my master node to connect to the NTP. It will adjust, no problem. So I'll just cancel that. This is node 1, node 2, master node. Okay, now let's talk about PD shell. PD shell is parallel distributed shell, which you can download from internet. I'm going to show you. I already have it though downloaded on my host machine. As you can see here, it's this pd shell.source.rpm. I already have it downloaded here, but from where to download it, I'll just show you that. Okay, let's go to home. I hope it's defined. Should come on. Okay, pd shell. Search the internet and you'll get it. Here, pd shell. Oh, this is parallel distributed shell. Okay, go to this page and download it. I've already shown you that you would be needing a source.rpm because we are going to recompile it. I've got a pathetic internet connection here, so bear with me the speed. I'll just pause the video. Okay, this is what I'm talking about. I've gone to this sourceforge.net, I've clicked various links, and after that I've reached here on pd shell or source.rpm. I've already downloaded it, so I'm going to minimize this window here, and I'm going to copy it, pd shell.source.rpm, over there. So scp 10.0.0.2:/root/pdsh pdsh asterisk to this place. Yes, red hat. Great, it's copied. Okay, so let's recompile it. rpm build -- rebuild pd shell. Please note that this pd shell does not need to exist on the compute nodes. It just needs to exist on your management node, so-called master node. Okay, so it's compiling, so I'll just pause the video. Okay, it's done now. It says that it has written these rpm files here in these directories, and this is the command which I use. I'm sorry, I'm sometimes too quick in typing the commands. This is the command I use to rebuild the source rpm, and it goes, everything went here there. So what I'm going to do is I'm just going to change directory into this directory here, and I'm going to just say that rpm -ivh pd shell dot asterisk. I don't mind debug info getting installed, no problem. Okay, so everything is installed now. Now pd shell works. What's pd shell? Basically, it's parallel shell. If you want to perform a certain operation on all the nodes or some nodes, one way is to manually log in through SSH to each node and perform the task. The second is you can just tell pd shell to do it, and it will go out and perform that task on all the nodes. It's very simple. So suppose you want to execute date command on all the nodes, or uptime command on all the nodes, or whatever. So you would just tell pd shell to do it, but in order for pd shell to work, it needs a machines file. So what I'm going to tell this pd shell is that there's a file named machines, etc machines. I'm going to supply that master node, node 1 and node 2. These are the three nodes which I'm going to use, or which will be used for pd shell. Now look, here's the beauty. pd shell execute on all nodes. Execute what? Let's say date. Simple. Great, it went out on all the nodes and it brought the output back from all the nodes. You see, they're all 100% at the same time. That's not the because of PD shell, it's because of NTP which we just set up. If you just go to node 1 and issue the NTP query minus print minus no name lookups, in simple terms, look here, NTP minus Q minus, it will tell you that's now bound to this NTP server. Great, fine, it's no big rocket science in it. NTP, okay, there's a beauty. Now I'm doing this everything manually on all the nodes. Why not use PD shell to do that? Okay, PD shell perform on all nodes, perform what? NTP Q minus P minus N. Great. So look at this. It logged on to node 1 and brought this output. It logged on to master node, brought this output. It logged on to node 2, brought this output here. Alright, now PD shell in place. Let's see, where are we? This is done. Now I need a central NFS location for some things to do. So what I'm going to do is I'm going to set up NFS on master node, CD to come back to home directory, and I'm going to edit the exports file, and I'm going to define that slash cluster is going to be read write comma no root squash comma sync for all nodes. Static means all nodes. Fine. So I save and exit, and I do a service NFS restart. Great. And I also specify that it should come up on boot time. I'm going to create a directory slash cluster. I should have created it before. And I'm again going to do a service NFS restart. Okay, fine. Okay, now I'm going to do going to create this directory on all nodes. So I'll just ask PD shell. Look at the beauty of PD shell. I'll just ask PD shell to do it for me. Please create slash cluster on all nodes. Fine. Make directory slash cluster. File exists master node. Okay. Fine. There's a method to mention only few hosts with it, or what I can do is, okay, I'll show you both ways. I can do a PD shell minus W node 1 and node 2 do this. Okay, node 1, this file exists. What about node 2? Slash cluster file exists. Okay, this is strange. I did not create these files over there. Slash, yeah, it exists. How come? Anyway, maybe PD shell created it and I'm not able to interpret it correctly. Let's check the minus L when it was created. Slash cluster, it was created about just now, 3 minutes ago. Fine, so PD shell must have created it. Fine. Now I'm going to mount slash cluster from master node on these nodes. Mount minus T NFS master node colon slash cluster to slash cluster here. Node 1 done, and I'll go to node 2 and I'll do the same thing. So why waste time? Let's copy this, paste it here. df minus ht shows that from master node you have this mounted here. Great. Fine. So next step would be to specify in the etcfs tab the same thing, so their reboot does not lose this. So slash cluster is mounted, no, uh, master node colon slash cluster would be mounted on slash cluster here NFS defaults 00. Please note that these defaults for NFS are not performance, they will not give you good performance, and you will need to replace this with good block sizes and other options, NFS options or mount options. But I'm at the moment, for the sake of example, I'm just mentioning defaults. So node 2 is done, node 1 Mpi etc fs tab, fine, go to end and insert, fine. So it will now, once the nodes will reboot, they will mount this mount point from the master node. Great. Just make sure that you, once the entire cluster is shut down, you boot master node first fully and then boot the compute nodes. Okay, so let's go back to master node, and now where are we in our list? So we have set up NFS, we have set up all nodes to mount proper NFS mount points, and now we need to create some ordinary user and set up its user equivalence. Great. So how do we do that? Okay, I'll mention here basically that the user I'm going to create is group. I'll create my Mpi group, and the user I will create as Mpi user, and Mpi group will have GID 600, Mpi user will have UID 600, member of Mpi group. Home directory in be slash cluster slash Mpi user. Good. This is going to be my setup. So I'll just log into master node. I'll do user add, before that group add minus group ID 600, and the group name is going to be Mpi group. Fine. And now I'm going to do user add minus user ID 600 minus group ID, primary group ID 600 minus home directory in slash cluster slash Mpi user, and I'm going to create a user named Mpi user. Why I use these specific IDs or numbers is because I want this to be persistent across the cluster. Means all nodes this should exist in the same way. So this directory is now created, but the users, since the directory is created on the shared storage or shared directory, it will be replicated or reflected across all nodes, but the user and group does not exist on all nodes. So what I'm going to do is I'm going to log on to node 1, which I am here, and I'll just create this group. I'll go to node 2, create this group. I'll go back to master node, copy this command again and go to node 1, press enter. Once I press enter, you'll notice it gives a warning that this directory already exists. Of course this directory already exists, because the first instance it was created on the shared cluster. So it's not a problem, basically, no problem. Just go to node 2 and go to node 2 and copy this, paste it here, fine. So my user and group is created on all nodes. So let's check our list. This one is done. Now let's check GCC. I should also mention G77 here. Okay, let's see if all of my nodes have GCC and G77. So what do? I do RPM minus Q GCC. I get 4.1.2. I check RPM minus QA pass through grep G77. it should show me a compatible library. It's not there. So what I'm going to do is I'm going to check yum list pipes through grep G77. okay, this library exists over there, so I'm going to tell yum to install this thing here. What is this basically? This is Fortran 77 compatible compiler. The reason is, and later on I'm going to use GoToBlast software, which will be used for for Linpack. Since I do not have Fortran 77 compiler with me, I'll just use the compatible G77 compiler, which is GNU 77 compiler in short. Okay, what I'm going to do is I'm going to tell I'm going to do this on using pd shell -w node 1 comma node 2 yum minus install this thing. Okay, do that. Great. So it's installing this software on both nodes. So pd shell saved my time. Good. Come on. Okay. Okay, this is being done now. Both nodes. So I need GCC and G77 on all nodes. So that's how that will be helpful later on. Okay, it's completed. Node 2 complete, node 1 complete, and master node I already set up myself. Okay, good. So we look good. Okay, now let's check our list. We have this prerequisites. Now we go for Mpi installation. So Mpi is basically message passing interface, is the language which is used to run a program, specially designed program on multiple compute nodes, on multiple nodes. Mpi can be downloaded from various places. There is OpenMPI, there are other MPIs as well. I'm going to download this special MPI for you from a special link. Let me find it out. There is one important step which I just missed. I just recalled that before installing Mpi, of course, I have to set up the ordinary user's SSH user equivalence, otherwise Mpi will not be able to work. So what I'm going to do is I'm going to switch user to Mpi user. Great. I'm going to generate its SSH keys as well. SSH key gen -t DSA. Press enter, enter, and RSA. Enter. Fine. Two keys are generated. Two key pairs are generated. So I'll just scp -r dot ssh from this master node Mpi user, this directory, to node 1 / cluster. Rather, it's not needed. Sorry. Why? Because this /cluster is shared across the entire cluster. So if you go to node 1 and switch to Pi user, you will see these files here. See this directory? It's already there. Change into this. This is the same which we just created on master node. Because the /cluster, I'll show you here, this directory is shared across all nodes, and this Mpi user's home directory is inside this shared storage. So that makes sense. Alright, so now let's try issuing commands as user Mpi user on all nodes. SSH master node, give me uptime. Good. Oh, it asks for password. Good. Reason is I made a mistake. That's simple. I generated the keys. Let's go to .ssh directory. I generated the keys, but I did not append these public keys into authorized keys file. So cat asterisk dot pub goes to authorized underscore keys. Great. So let's go out a bit and let's ask this SSH to show me the uptime of the same node. Good, it works perfectly. Now I say, okay, show me the uptime of node 1. Good. And node 2. Great. Another check is you can use hostname command, that it will go to the other node and show its hostname, output of the host name. So I'll just do node 1. Good. It shows that it logged into node 1 and it issued the hostname command which gave out node 1 and node 2. Good. So it's working properly. Even I can use pd shell to do this -a and do what? Do hostname. Great. So fine. So the user equivalence for MPI user is now set up properly. Now I can move on and I can download MPI from this location, which is mcs.anl.gov/research/project/mpi so and so. Okay, it has so many versions of MPI, the latest one being 1.1 beta 1, I suppose. What I've done is I've already downloaded this 1.8 0.8 for you. Let me show you where. It's here on the host machine. This is, where is it? It was supposed to be here. Oh, I missed it. Okay, I just copied these files from another location to this directory on this host machine of mine. This is MPI ch2, which is MPI version 2. This is high performance linpack version 1. This is high performance linpack version 2. This is go to blast directory, basic linear algebra library. Okay, so what I'm going to do is copy this MPI ch2 to the home directory of the user of my master node, scp slash 10.0.0.2 colon slash slash. Okay, let's specify root here, slash root slash MPI asterisk to this place. Yes, Red Hat. Okay, so MPI ch2 is downloaded, copied in this user's home directory. Here you go. You can download it in another directory. Basically, let's move it a bit up. Oh, it's not owned by this user. Okay, let's do exit. We are now root on master node. Let's go to slash -l. So this cluster directory needs to be owned by MPI user colon MPI group minus recursively. Oh, sorry, slash cluster minus recursively. Okay, check again here. Okay, so switch user back to MPI user and move MPI ch2 ... Okay, so it's gone from here. Let's go back one step. Now we are in this directory and list -lh is showing us that MPI ch2 17 megabytes is here. Now I'm going to uncompress this untar xzf MPI ch2 this directory here. Untar. Okay, we got this directory, cd MPI ch2 directory list, and we've got so many files here. Now I'm going to do the configure part, which is which would look like /configure -- prefix is equal to /cluster /mpi-ch2. This is going to be a new directory in /cluster. So on a VM machine, on virtual machine, this process is going to take 2-3 minutes. So I'll just press enter and I'll pause the video. Okay, this is complete now. What I'm going to do is stop this video here. I wanted to do this MPI in part 3, so this video segment is already too long now. I'll just stop it and I'll deal with this MPI in the next video. Thank you for watching.